Okay, good morning. So let us start the lesson, and it's better to keep the door open. So section 5.2, which is talking about an equation for any kind of circle, is actually been omitted from this course. So that's at least a little bit good. I don't know, but that is not very reasonable to omit that one. But anyway, we just go to this trigonometry in the unit circle, which is actually very important, not just for this course, even for Math 4. So the first chapter in Math 4 will start again from trigonometry in the unit circle, okay? I really don't like this attitude to repeat something exactly again later. I don't know what the problem is, why we should do that, because if you are going to talk about equations, okay, just do it once, finish it, yes. And then we can study something better in Math 4. But now we have to study equations here, and again, trigonometric equations in Math 4. Anyway, we have to follow the rules. Anyway, so what is the trigonometry in the unit circle? So if you remember, we just talked about the trigonometry in the right angle triangle. It has its own limitations, yes, because you cannot talk about, for example, of sine of 150 degrees, yes, because there are no angles 150 degrees in the right angle triangle. Okay, but if you take your calculator and type sine of 150 degrees, you get a number. So it means that there should be a way to understand what is the meaning of sine 150 degrees. Okay, so now this is the starting point of that. So what we need to know, first of all, what is the unit circle? That is a phrase that when you see this, it is referred to this unit circle. Unit means that its radius is one length unit, whatever the length unit is. And then, even though it is not mentioned where the center is, by convention, the center is the origin. Okay, so you have a unit circle, you have a circle centered at the origin, and its radius is equal to 1. Yes, so something like this, if I can draw it. So that is the unit circle. Not only this, you also consider a direction for it, okay? And this is convention again. If you go counterclockwise, this is positive direction. If you go clockwise, by convention, this has been chosen to be the negative direction. Okay? And then there is also another important point on the unit circle that you need to remember, and that is the point of intersection of the unit circle with the x-axis. So if you don't mind, let me call it A here, and the origin is usually denoted by O as before. So, first of all, I want you to understand that whenever we talk about an angle, angle has two arms or two sides, yes? One of them is this one, the other one is that one. Okay, so you always, just remember this adverb always, you have to put one arm on this horizontal line OA, okay? And then you are free to move the second, so you are free to choose the other arm, of course, depending on how big this angle is, yes? So if, for example, it is 30, you start always from here, and when I say 30 degrees, without any signs, I of course mean positive 30. So you start rotating 30 degrees in the positive direction. For example, you reach to somewhere here, and this gives you a point, I call it B, and this angle that you see here is called positive 30 degrees, okay? So this is important that you always start from here. Of course, you can also start from here and make an angle 30 degrees, no doubt about it. But by convention, when I say angle 30 degrees in the unit circle, I mean that you have to start from OA and start rotating, okay? Yes?
What kind of sign is that movement going to have? Is it positive or negative from like the other area? You know?
So we will come to that, okay? So we go from here 30 degrees. But if I tell you minus 30 degrees, yes, which was not possible in the right angle triangle. In the right angle triangle, we didn't have negative angles, but here it makes sense. You start again from here. You rotate 30 degrees again about O, but this time, because of this negative sign, you go in the negative direction. So if you start from here and rotate from here to here, this becomes negative 30 degrees, yes? And then you end up with another point C. For example, if I go 120 degrees, what happens? Yes?
I mean, like the other area.
We will go to that, just wait.
Sorry.
Okay, what about the other area? Okay, what is your concern?
Like that side.
So what is the problem? So we
And
go
like,
120 degrees, for example.
Would that still be like...
Don't wait. 120 degrees. I start from here, and I rotate 120 degrees in the positive direction. Yes? This means that I start from here. 120 is a positive number, so I have to rotate in the counterclockwise direction. But how much? 120. So I start from here. I go up to here. It is not enough yet because this is 90 degrees. So it means that I have to cover 30 degrees more, yes? And then this becomes, but be careful, not this angle. You have to measure the angles always from the horizontal line. So this becomes 120 degrees positive. Yes? So what's the problem then?
I was thinking that, okay, if we have OA on that side, why can we still say that there is another A on the other side and count on that direction?
OA is always this line, yes? Only this line. By convention, there is nothing very specific about choosing that point, but we have to choose an origin for measuring my angles, and this is the convention that we use in the books and everything, okay? But what does matter here is not actually the... So first of all, you see that in geometry, I didn't have negative angles, but in trigonometry, I could have negative angles. That is one thing that I wanted to know. In geometry, the smallest angle is 0 degrees. The biggest angle is 360 degrees. We don't have more than that. But in trigonometry, we can also have 1000 degrees. But of course, what does it mean? It means, for example, what is 720 degrees? What is 720 degrees? I start always and always from here. Because 720 degrees is positive, I have to rotate about O positively in this direction. But how much? 720 degrees. Okay, I start from here. I go back and rotate and rotate and rotate. I reach here. This is not enough yet because this is just 360 degrees. I have to move another one and I come back here again. Okay? So you see that I will end up exactly at the same point A. So this point that you see here corresponds to 0 angle. Also corresponds to 360 degrees. Also corresponds to 720 degrees. Yes? And of course, how many names I can assign to the same point? But can you tell me a negative number, a negative angle whose final point is A?
Minus 360.
Minus 360 degrees. So instead, I start from here, I rotate 360 degrees in the negative direction, but that is clear, I will end up again at the same point. And this is very, very important, by the way. If you understand this concept, then most of it is done. So this is important, that what matters in the coming lesson is not the magnitude of the angle or the sign of the angle, is the end point of the angle. Okay? So it means that I might have very different angles. Don't cut. I might have many different angles, but they are ending at the same point. For example, if I ask you, can you give me another angle whose final point is B? So one of them is 30 degrees, but what is another one? Yes?
Minus 330.
No. Minus 330, yes, that's right. So you say that I start from here, minus 330 degrees, you rotate in the negative direction. If you are not careful and rotate up to here, it is 360 degrees, but you told me 330. So it means that you stop 30 degrees before reaching to this one. So that's correct. So this point that you mentioned, I can call it 30 degrees, not call it. The final point of 30 degrees is B. As Maximilian mentioned, minus 330 degrees is also ending at B. Okay, can you give me another positive angle which ends at B?
390.
390 degrees is another angle that ends up exactly at B. So you see that if I want to give an address for you to find a point on this circle, I can give you infinitely many numbers, yes, so that you can end up here. Of course, in this case, I would prefer to give you 30 degrees, otherwise I am just sending you just going around and around and reach to the same point. Unless I am mentally sick, there is no reason to do that. Yes, I can give you the shortest path. So, this is important that you know that there are many different names that you can assign to different points on the unit circle. Okay, and then of course, the best number, the best angle that we can assign to A is probably 0 degrees. I hope that you agree with me. These points, by the way, are important. These 4 points are also very important in trigonometry, yes. Okay, so what is the best name for it? The smallest angle, the smallest non-negative angle that you can associate with A is what? 0, yes? But what is the smallest positive angle that you can associate with here?
90.
So I think, yes, let me write them down. So this is 0 degrees, this is the best name. This one is 90 degrees. What about this one?
180.
180. And what about this one?
270.
270 degrees. And of course, 360 degrees, I will return back to the same point. So remember these numbers. These are famous numbers in trigonometry. Okay? Now, we want to define again. So if I would say that let alpha, let me write theta. So let me just stick to this convention. I use theta for my angles. Let theta be a trigonometric angle. So what do I mean by trigonometric angle? Let me repeat it again. When you say an angle is trigonometric, it means that you might expect negative angles. You might expect angles larger than 360 degrees. So that's the meaning of trigonometric angle. And I think you agree with me, there is no problem, yes? So you can talk about 1,200 degrees, yes? You just start from here and start rotating around and around to see where 1,200 ends. Okay, let theta be a trigonometric angle. Okay. And let the point A with coordinates x and y be the end point of angle theta on the unit circle. On the unit circle. Okay? Yeah, don't lock the door, please.
No.
Be the end point of theta on the unit circle. Then sine theta semicolon equals to means is defined to be equal, okay? Y. Cosine theta is defined to be x. And tangent of theta is defined to be y over x, of course, if x is not 0. So what does this mean? It means that if I give you, let me draw another picture. So this is your unit circle here. So this unit circle will be with you whenever you want to study mathematics from now on. So please pay attention to learn it very quickly. So this unit circle that you see here, you give me a trigonometric angle theta. It might be negative, it might be even larger than 360 degrees, I don't care about that. I care about that I start from OA as usual, and I will start rotating about the origin with the amount of the angle that you have given to me in the right direction based on the sine of the angle. But the point is that no matter how big angle is, and then no matter what the sine of the angle is, I will end up at one point on the circle. That is clear, yes? So for example, assume that you end up here. Okay, so what happens, this I will call it, so if you don't mind, let me change this letter from A to B so that you're not confused with that A. Okay, so I will end up here, B. But this now, try not to see this circle. Then you have a point in the coordinate system. There is an x coordinate for it. There is a y coordinate for it. What I am telling you is that x is the cosine of the angle, y is the sine of the angle, and if you divide y by x, it is called the tangent of the angle. Yes?
So is B the endpoint now?
Here B is the endpoint, yes.
Okay.
But, so the B is the endpoint, but of course here, it is not wrong if I say this is theta. Yes, that is also clear, but there is no guarantee that theta is this one. It might be even bigger, you know. I don't know what theta is, but let us not write theta. Of course, if you want, let me just write theta. But I want you to understand that this is one of those thetas that I end up here. Yes, you know that. And this is something very interesting. So it means that the magnitude of the angle is not matter. It doesn't matter for sine, cosine, and tangent. What matters are the coordinates of the final point. Because, so here, for example, if I want to answer what is sine of 30 degrees, this is 30 degrees, this is my B. What I do, I find the y coordinate here, whatever it is, forget about this, you get a number here. That number, whatever it is sine of 30 degrees. But what about sine of 390 degrees? What about the sine of this one? Of course, you don't know sine of 30, you don't know sine of 390 degrees, but what you know, if you understood what I said, you know that they are equal. Why? Because 30 degrees is different from 390 degrees, of course. But the final point for 30 degrees is B, and the final point for 390 degrees is also B. And sine of this is the y coordinate of B, sine of this is the y coordinate of the same point B, so they have to be the same. So that is very important, that even though the angles are quite different, but the sines are the same. Is that understandable? But that is the definition of sine, cosine, and tangent. For example, let us be a little bit more concrete here. Okay, for example, based on what I told you, can you calculate, or can you determine, it's a better word, can you determine sine of 90 degrees? Can you determine cosine of 90 degrees? Do you remember we had some problems with this 90 degrees because trigonometry in right angle triangle only works for acute angles, okay? So what can I say about sine of 90 degrees? The first thing that comes to mind, let me start from scratch. I will do this. I immediately draw a picture for myself, just roughly, you don't need to be precise at all. Okay, and then I will try to locate the end point of this angle that you have given to me. So where is the end point? The end point is here. Yes, this is, I start from here always, and I rotate 90 degrees up to here. And I get a point, I call this point B. I want to read the coordinates of the point B. So that is up to you to read it for me. So what are the coordinates of the point B? Remember that this circle is a unit circle. So its radius is 1. Yes, Rocco?
0, 1.
It is, the x-coordinate is 0, it is clear because you are on the y-axis, so the x-coordinate is 0, but what is the y-coordinate? The y-coordinate is this length, but because this circle is the unit circle, its radius is equal to 1, this is 1. Yes? Now, that's it. If I ask you what is sine of 90 degrees, you go and find the final point corresponding to 90 degrees and take the y value, which is 1, and write it here. So sine of 90 degrees is 1. And if I ask you what is cosine, cosine is what?
0.
The x-coordinate, which is 0. And then y divided by x is what?
Undefined.
Is undefined here, because you see I divide y by 0, undefined. And that is possible. If you take your calculator and punch this one problem, you get an error message or something. So tangent of 90 degrees is not defined, okay? So that is the idea of trigonometry in the unit circle. So let us just try to practice this a little bit more. For example, can you tell me, so because let us consider these important points, yes? So let me start with this point. There is one name for this. The famous number for A is 0. So let me ask you, what is your opinion about these numbers? So what is your opinion about these numbers?
Very nice number.
So I need to do, well, let me repeat this so that you can learn it better. So I need to first locate the end point for the 0 degrees. But where is the end point for 0 degrees? A itself, because I start from here, I'm not allowed to even budge, yes, because it's 0 degrees. So then what is this one? The end point of 0 degrees. So I have to read the coordinates. So what are the coordinates this
1
time?
and 0.
X is 1,
1.
y is 0. But you take y, remember, y and put it in front of sine. You take the x value and put it in front of cosine. And then you divide the y value by the x value. So which is 0. So sine of 0 degrees is 0, cosine of 0 degrees is 1, and then tangent of 0 degrees is actually 0. And this is something that you get it in the formula sheet, but it is really handy to be able to visualize this quickly to be able to answer the questions. Because these are famous angles. Let us do it for every one of them, okay? So what about what about the other angle, but which is famous? So we did 0, we did 90 degrees. Let us do now 180 degrees, yes? So what is the sine, cosine, and tangent of 180 degrees? Okay, so I want to answer these questions. So sine of 180 degrees, cosine of 180 degrees, and tangent of 180 degrees. Okay, so what I have to do, again, let me just repeat the process. You always start from this line, and then go and find the final point for your angle. So it is 180 positive, so I have to rotate in the counterclockwise direction. How much? 180. So it is clear if I rotate 180, I will end up at this point, yes? So what are the coordinates of this point? The x-coordinate is how much?
1.
Not 1.
Minus 1.
Minus 1, because the length is 1, but you are in the opposite direction of x, so it's minus 1. And what is the y-coordinate? 0. So you take the y-coordinate and put it in front of sine. You take the x-coordinate and put it in front of cosine. And then you divide this one by that one, which is 0 again, is tangent of 180 degrees. Okay, let us do the next one as well. So sine of 270 degrees, cosine of 270 degrees, and tangent of 270 degrees. Okay, then again, I always start from this line and I start rotating to find the endpoint for my angle. This is 270 degrees positive, so I have to rotate 270 degrees in the positive direction, which is the counterclockwise direction, and I will end up here, yes? 90, 180, 270, I end up here. So what are the coordinates here now? What is the x-coordinate?
0.
0, but what is the y-coordinate?
Minus.
Minus. So you take the y-coordinate and put it in front of sine. You take the x-coordinate and put it in front of cosine. And then you divide this by that, which of course again, undefined. So tangent of 270 degrees is also not defined. Yeah, I mean that is a very, very simple idea. But do I really need to calculate sine, cosine, and tangent of 360 degrees? No, because even though the angle is much bigger than 0 degrees, but it will end up exactly at the same point, A. So it means that without any calculations, you know that sine of 0 degrees is exactly equal to sine of 360 degrees. The cosines are also the same, the tangents are also the same, because they are actually the same endpoint. Yes? So that is very important to understand. So for example, let me try to, of course it is hard for me to draw good pictures on the board, and it's hopefully you can visualize it somehow. The idea of GeoGebra is better, but anyway. So let me ask you, what is the relation between sine of 20 degrees and sine of 160 degrees? Okay? I am intentionally writing these angles because I myself don't have them in my memory. I don't know what is sine of 20 degrees. I have to use the calculator to answer. But the point is that without calculator, if I have a good intuition of what is going on, I can find the relation between these two numbers. Okay? So, sine of 20 degrees and sine of 160 degrees. I want to discover the relation between them. This argument that I am telling you is extremely important. Simple, but extremely important. Okay? So what you do, assume that this is your unit circle. You want to understand the relation between these two. So first of all, let us try to sketch something about 20 degrees and 160 degrees. So 20 degrees, I start from here again. I start rotating 20 degrees and I stop. Yes? This is my 20 degrees. Assume that. But now I want to look. So this is the end point. If I tell you, so this is the origin of the circle. This is the origin of my coordinate system. The end point for 20 degrees, assume that turns out to be here. But now let us try to understand where is the end point corresponding to 160 degrees, okay? Of course, you understand what does it mean. I start from here, always and always from here. Don't get confused and start from here. No. Every angle you're talking, you always start from here. And this time rotate 160 degrees. Of course, it is clear that I have to pass 90 degrees, but I have to stop before this because this is 180 degrees. So I have to stop somewhere there, okay? But can you tell me, okay, of course I can draw that, but can you tell me where I will end up if I do this by words? Yes, Abdullah?
It's corresponding to the 20 on the other side.
So, yeah, more precisely.
Kind of like you mirror the...
Yeah, mirror image. Yes, this would be the mirror image of B with respect to this line. Agree or not? Yes? So I hope that you agree that it's not hard. Of course, if you have a better drawing tool in your hand, it would be better. But of course, it is also understandable. So if I start 160 degrees, then it means that why I end up here exactly in the mirror image, because if this is from here, be careful, from here to here is 160 degrees, and this is the end point, which I call it C. Yes? Okay, and then if it's from here to here is 160 degrees, what is left? 20 degrees. So I hope that you agree, because of symmetry, you can realize that this is exactly the mirror image of that point here. Is that understandable? So now, if I ask you, do you know sine of 20? You would say no. But you say that this point has two coordinates. I don't know, let me call it x and y. Y is the sine of 20, which I don't know. X is the cosine of 20, which I don't know. But I call one of them x, the other one y. But the point is that, can you, using these numbers, read the coordinates of this one for me? Yes, that's the point. So if I ask you, do you know the coordinates of C, I would say no, but I can immediately make a relation between these coordinates and these coordinates, yes? So,
Minus x and y.
so minus x and y, is that understandable?
Yeah.
Because the height of this point and the height of that point are exactly identical. So if the y coordinate of this is y, no change will happen for the y coordinate here. But if the coordinate of this one is x, because you jump to the opposite side on the negative part, even though this length and that length are equal, but one of them is in the positive direction, the other one is in the negative direction, so that becomes minus x. Okay? Now let me ask you a question. If I ask you sine of 20, what do you answer? You say that sine of 20 is the y coordinate of the final point, which is y. Now if I ask you what is sine of 160 degrees, so you need to go and find the final point of 160 degrees. We already did. That is C. And then you read the y coordinate for that final point. What is that? Y again. So this, if you ask me, do I know y? I would say no. But I realize sine of 20 is equal to y, sine of 160 is equal to the same y. So what does it mean? It means that these two numbers are also equal. So this means that sine of 20 degrees is what? Equal to sine of 160 degrees. You can confirm this by writing in your calculator this minus that, and then hopefully you will get exactly 0. Yes?
So can we conclude that the sine of supplementary angles are equal?
Yeah, exactly. Now I will write this as a remark at the end. But do you mind if we connect the cosines as well? So if I ask you the same question regarding the cosines, how do you answer that? I would ask you how cosine 20 is related to cosine 160 degrees. You don't need to do any extra job here. Everything we need is done here. So what is the relation between them? So you say that cosine of 20, I go and find the final point of 20, which is B, and I read the x coordinate. Whatever this number is, which I don't know, is equal to the cosine of 20. And if I ask you what is cosine of 160 degrees, you will start from here and go and find the final point of this angle, which is this one, and read the x coordinate of that point, which is minus x. So you see, I don't know x, but I know that this number is exactly equal to x. This number is equal to the negative of x. So this means that how these numbers are related this time? They are opposite. So this means that cosine of 160 degrees is not exactly equal to cosine of 20, but it is negative cosine 20. So these kinds of things that we are discovering now is extremely important in trigonometry. And if you are very good at it, you can I would say that most part of the trigonometry you are relieved about, okay? Any questions here? So as Kajal said, we can actually make a rule, and I really recommend you to memorize this rule. So first of all, what was the name of supplementary angles? So two angles that add up to 180 degrees is called a pair of supplementary angles. But something interesting can also happen. So for example, 20 degrees and 160 degrees, this is a pair of supplementary angles. But nice thing is that I can say that 190 degrees is also supplement to minus 10 degrees. Because when I add them, it becomes 180 again. Okay? So that is also important to realize that this rule that Kajal mentioned, and I want to write this as a remark, and I really emphasize to memorize that, is that it works for any pair of supplementary angles in the realm of trigonometry, not just geometry. Yes? So in trigonometry, we can also have negative angles. By the way, let us try to discover this geometrically. that the same relation holds for -10 and 190 degrees. Okay, so what can we do here? Okay, so let us try to understand it from a geometrical perspective by drawing shapes or figures. Okay, so where is -10 degrees? Of course, I cannot exactly show where it is, but we understand. -10 degrees, I start from this line, which is the origin here, but I go 10 degrees, because of negative sign, I go in the opposite direction. So this is -10 degrees. Assume that this is -10 degrees, so it ends at some point B, whose coordinates are x and y. If you ask what are they, I need my calculator to answer. But this is x and y. But where is 190 degrees, by the way? 190 degrees, you have to start from here. If you rotate positively up to here, it is not enough yet. You have to go a little bit more. How much more? 10 degrees more. And that's exactly the same scenario, okay? So I have to draw it better. So be careful. The second line starts from here and goes here. This is 190 degrees. But now let me call this point C again. And now I ask you the same question. If you give me x and y, assume that I have given you x and y, and I ask you to find the coordinates of this. Of course, because if I ask you how much this degree is, this is 10 degrees exactly, so you can feel the symmetry immediately, because this sector is exactly identical to that sector. Okay, so can you tell me what are the coordinates of C if I give you x and y?
Minus x, y. Minus y.
No, not minus y. Y itself is negative.
Minus x.
Minus x
And y.
and y again. Yes, whatever this is the same. This is negative. This is also negative, but we don't need to care about it. But you see the same relation holds, yes? So you see, if I ask you what is the sign, by the way, I write it like this. What is the sign of -10 degrees? You would say this is y. If I ask you what is sine of 190 degrees, you would say it is y again. They are also.
Don't we determine the coordinates of point B according to point A or in respect to
No.
like the origin?
No.
No?
We are writing the coordinates with respect to the coordinate system, not with respect to this.
Okay.
When you want to write the coordinates, you momentarily forget about the circle, and you see a point on the plane and try to read the coordinates.
And
It has
even in
nothing
that
to-
case, wouldn't y be negative because
Yeah, y is negative, but I don't care.
Shouldn't
If
be
this
like
y is
right
minus
here?
1, if this one is minus 0.5, it's of course wrong. This y is the same number.
In the,
So the negative is implemented in the y itself. So yes, you are right, y is negative. But if this is negative 0.5, my point is that this is also negative 0.5. So they are exactly the same. Is that understandable?
Yeah.
So this is actually a really important aspect of this new geometry. Okay, so I would recommend you to write this as a remark and memorize that. Okay? So let me write it mathematically. If alpha, beta, trigonometric angle, yes? Angles. It means that one of them might be negative, or two of them might be negative, or even one of them is much bigger than 360 degrees. And then another thing is that alpha plus beta is 180 degrees. Supplementary, if you want the word supplementary. Yes? Then we conclude two things today. Yes? We learn that sines are exactly equal without any changes at all. But cosines are opposite. Okay? But of course, cosine alpha is negative of cosine beta. If you want, you can say cosine beta is negative of cosine alpha. It doesn't matter. But can you also predict what will happen for tangents?
Negative.
Yes, that's also negative. By the way, I should have said this before. Do you remember how did I define these things? Sine theta was the y coordinate, cosine theta was the x coordinate, and do you remember what I defined for tangent?
Y divided.
Y divided by x. But what is y? Y is sine. What is x? X is cosine. So that's extremely important formula to remember in geometry, in trigonometry. So tangent is always sine divided by cosine. Extremely important. Okay, so you can also start from scratch, but this is easier. I divide sine by cosine, it becomes tangent. I divide sine by cosine, it becomes tangent. But because one of them is positive, the other one is negative, when I divide, the negative sign will survive, yes. So by the way, it doesn't matter how big the angles are. For example, if I take one angle 390 degrees, what is the supplement of this? Yes?
Minus 30. Oh no,
No.
sorry.
Oh, it becomes 360 in that case. What is the supplement to 390 degrees?
540.
No. You need to add them, it becomes the result should be 180.
150.
Minus 2.
Minus 200, minus 210. Yes? It's minus 210. Why? Because if I add this to that one, it becomes 180. So this means these rules are also valid for them. Okay, so you can check it if you want to geometrically. You have to be patient, find the final point for this, find the final point for this, and then you see that this will work. Okay, by the way, if I ask you immediately, this is also good to know. This is called the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. That is also, because I told you that this is the positive direction, so this quadrant is the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant, yes?
Oh,
Yes.
isn't 390 degrees the same as 30 degrees?
No, it is the same, yes. Then
The
what's
first quadrant is
okay, then what?
and
It is not the same.
it's not the same.
Of course it is not the same. 390 is 390 crowns the same as 30 crowns. So I give you 30 crowns, please give me 390. So they are not the same, but they end at the same point.
Okay.
And then
And the
for
supplementary are
sine,
different.
cosine, and tangent, what matters are the final points.
Yeah.
Yes? Okay, so sine of 390 degrees and sine of minus 200 degrees, you can check with your calculator, they are exactly the same. And make sure that, by the way, for national exam, your calculator is in the correct mode. So, I don't know, punch, for example, tangent 45. If you get 1, it means that this is in the correct mode. And then you will have a small d, I think, on the display of your calculator showing that it is in degree mode. So be careful in the national exam, make sure that this is the correct mode that you're using. So I want you to memorize that. So if I want to express it in words, I would say that if I have two angles that are supplementary, sines are equal, cosines are opposite, tangents are opposite. It's a better way to remember it in that way. But let us make the problem a little bit more complicated, and that is about complementary angles. You need to have a better visualization here. That's also extremely simple. But I want to make sure that you really understand what is going on. Let us consider two angles. Let me make it very simple first. For example, 15 degrees and its complement. What is the complement of 15 degrees? Do you remember? Two angles are called complementary if they add up to 90 degrees. Okay, so if I say that what is the complement to 15 degrees is 75 degrees. So let us try to understand the connection between sine and cosines of 15 and 75 for the time being, yes? So I will say 15 degrees and 75 degrees, we want to explore the relation between sines, cosines, and tangents, okay? So let me just try to more or less draw a good picture here, and then So 15 degrees, it means where I start from here, start rotating 15 degrees positively, so then I stop. So then I hope that something like this will happen. So let me a little bit exaggerate so that you can see it. Might be 15 degrees is a little bit smaller, I don't know. But assume that this is 15 degrees. The point is that this is O, this is A, and then you end up at a point which is B. If I ask you, do you know the coordinates? By the way, can you use your calculator to read the coordinates for me? In this picture, I give you this, might be this an exam question or in the national exam, they might give you a picture and then say that write these numbers there. So what do you write for X? You use your calculator and tell me, what do you find for X? If I ask you what do you find for X, which one you calculate using your calculator? Cosine, because X is cosine. So you punch cosine of 15, you get a number.
0.965.
Okay, whatever you get is, by the way, is it understandable it should be very close to 1?
Yeah.
Yes? Because 15 degrees is very small. So when I go a little bit higher, the x coordinate is from here to here, which is very, very close to 1. Yes? But then, what do you predict for sine? It should be a smaller or not? Because sine is the height. If this angle is so small, not so small, it's 15 degrees, okay? And it means that this length should be relatively small. So it is very clear that you could predict that cosine is larger than sine by this picture. Yes, because cosine is the x coordinate and sine is the y coordinate. Because 15 is a little bit narrow, so you could guess that this is. Where do you think they become equal, by the way? Is it possible that sine becomes equal to cosine?
Yeah.
But yes, where is that?
45.
45, yes? If I go 45, I want to just test your understanding, it's good to know. If I go in the middle, and then it is hopefully clear for you, the x coordinate and the y coordinates become exactly the same, because this becomes 45 degrees, and if it's 45 degrees, they are the same, yes? So it means that you can test it. Sine of 40 minus cosine of 40, sine of 45 minus cosine of 45 is exactly 0, yes?
So, are there any questions when the middle point isn't the origin?
No.
No.
Middle point, you mean this point?
Yeah.
This is called center.
Okay.
Middle point is a Swedish name, I think.
Okay, but
Yeah.
the center of the circle
Yeah.
is always the origin. There are
No,
no
in
questions.
trigonometry, yes.
Yeah.
In the section that we skipped, because it has been omitted from this course, yes, of course, you can talk about the circle here, wherever you want, yes. But that is not, but for trigonometry, we always care about the circle centered at the origin, yes. Okay, so at least these things you understand now, because if you understand the unit circle, I would say that 90% of the trigonometry is done, of course. There are a lot of formulas in trigonometry, but the most important part is here. Okay, so you know how to calculate these numbers if this is given in the national exam. Might be an E-level question, they draw a picture for you and then ask you, okay, using the calculator, write a number there. Okay, so you know what to do. But here, I really don't care to bother about finding the precise number. So let me just assume that one of them is X, one of them is Y. But this is a little bit harder. Now I want to find 75 degrees. So what I have to do, let me change my color. So I start from here, but I go 75 degrees. You see that if I go up to here, it's much more than I need. More than I need, yes? It is how much more? Because this is 75 degrees, where should I stop? I will start from here and go 75 degrees, okay? So something like that. But be careful, I am also measuring from this part. So this is 75 degrees. But if I ask you, can you also tell me where is 15 again? You would say this part, this narrow part that is left here is exactly 15 degrees again. But be careful, when I say 15 degrees, you are not allowed to show this, you have to show this, because I have told you that you have always to start from away. Okay, but this is what you see. And then, let me ask you one question. This is a little bit more tricky than before. So I tell you these numbers, x and y, and I ask you, can you tell me the coordinates of this point based on those numbers? Just a little bit. Yes, Abdullah?
I believe that the y value is going to be the x value for the,
Very good.
and the opposite is going to be.
Yeah, it's not understandable for everyone. Yes, thank you very much. So this becomes y and x. Why is that? Because, let me just try to convince you. When I say x, what do I mean in this picture? When I say x, I mean from here to here, yes? From here to here is x. From here to here is y. Now, look at this triangle here. First of all, if I ask you what this angle is, what is your answer?
15.
15 degrees. Because from here to here is 75, the whole thing is 90, so what is left over for me is 15 degrees. Okay, and then this hypotenuse is equal to this hypotenuse, because this is a right angle triangle here. This is also a right angle triangle. I am trying to convince you that these two triangles are congruent. It means that they're exactly of the same size. Why is that? Why OB and OC are equal? Yeah, very simple, yes?
The radius.
They are the radii of this circle. So that is one unit, that's also one unit, so they are equal in size. Okay? And then you have one angle 15 and one angle 15. So these two triangles become congruent. When they become congruent, it means that this length, whatever it is equal to this length. So if this length is x, what is this length? X. If this length is y, what is this length? Is y. But I hope that you don't get confused right now. If I ask you what are the coordinates of this point, you look at the y value and the x value. But the y value is x, so I write x. And the x value is y, so I write y. Is that understandable? Everyone happy? Okay. Now can you tell me what is the relation? If I ask you sine of 15 is what? You say sine of 15 is y. If I ask you what is cosine of 15,
That's also what.
it is
X.
x. Now if I ask you what is sine of 75, you go to 75 and read the y coordinate. What is the y coordinate? X. And if I ask you what is cosine of 75, you go to 75 and read the x coordinate. What is the x coordinate? Y. So you see that if I tell you sine of 15 is equal to sine of 75, no, that is not true. But sine of 15 is y, cosine of 75 is also y, and they have to be equal. Yes? So this means that sine of 15 is equal to cosine of 75. And vice versa. Sine of 70, so cosine of 15 is equal to sine of 75. So we are discovering some relations. If I ask you what is tangent of 15, how do you answer that? So tangent of 15 is the y coordinate divided by the x coordinate. If I ask you what is tangent of 75, you do the same thing, by the way. You go to 75, you divide the y coordinate, which coincidentally is named x, divided by the x coordinate, which is named y in this case. And then there is a relation. They are reciprocal of each other. One of them is y over x, the other one is x over y. So you immediately get this result back again. Do you remember we had this before? 75. The product of these two becomes what? 1. Of course, for this 15 and 75, I really didn't need this setup, because we already did this, if you remember, when we were doing trigonometry in a right angle triangle. But of course, we are getting that back, and that is why it's important. If we didn't get this back, this would be a contradiction. Mathematics would collapse, yes? Okay, so that's the point. If you want to write a remark for this, which I strongly actually recommend you to memorize again after that. So what can I write it in words? Yeah, just say something that we can remember, yes? Mnemonic or something. If I have complementary angles, sine of one of them is equal to the cosine of the other one, yes? And the product of the tangents is equal to 1. So let me write this as a remark again. And by the way, complementary in trigonometric sense, not only geometric sense. For example, 100 degree is complement to what? Minus 10 degrees. Because they also add up to 90. And the rule also works for this case as well. Yeah? Okay, so remark. What should I write? So the sine of a trigonometric angle is equal to the cosine of its complement. And vice versa, yes. Moreover, the product of tangents of complementary angles is equal to 1. Something like that. You can write it in your own language, but the content is this. Okay, one thing is left. They haven't talked in the book, but this is extremely important. You should have a question at this point, don't you? The question, yes?
Or I don't know, it's like, how do we find them? Or like, how do we find the coordinates for them? Is that the question?
No, that is a little bit technical. Before that, because you see that I defined you sine and cosine and tangent before using the right angle triangle, and now I am redefining them again, sine, cosine, and tangent in a different setup. Okay. But do you think they are different or they are the same? This is a very important question to address. Of course, this is extremely important to see why. Of course, some of them will not work for the right angle. If I have a negative angle, of course, I don't have any overlap between this new concept and the previous one. If I have a number larger than 90, if I have an angle larger than 90, there are no overlaps between this setup and the setup that we had in the right angle triangle. But if I have acute angles also can happen in the right angle triangle setup. Do you understand what I mean? For example, if I tell you 30 degrees, for 30 degrees you have two ways to understand the sine of 30 degrees. Either you use this setup to read the y coordinate of the final point, or you draw a right angle triangle whose one of the angles is 30 and try to measure the opposite side and the hypotenuse and then divide them. So, but this is an extremely important question to at least think about. Why sine of 30 in this setup turns out to be the sine of 30 in the other setup? If that is not the case, I am in trouble, yes? I have to change the name. I could call the other one sine, the other one something new, I don't know, sine prime or something, yes? First of all, I want you to think about it. Do you understand the question? Let me repeat it. If I ask you, calculate sine of 120 degrees, could you do it in right angle triangle? No, because 120 degrees cannot appear in a right angle triangle. So no, if I ask you this, you don't get confused. There is only one setup that you can answer this question, and that is this. That's no problem. If I ask you sine of minus 10, could you do it in the previous case? No, because minus 10 degree doesn't appear in a right angle triangle. So of course, if I ask you questions regarding them, there is only one setup that you can answer these questions, and that is the new generalized extended version of trigonometry. But if I ask you sine of 30 degrees, you can answer it using this setup. You could also answer it using the right angle triangle setup. And the setups are quite different, yes? What is the guarantee if I use, so let me just make it clear. I ask you to calculate sine of 30 degrees. Assume that for the time being you have measuring tools, okay? So you put your ruler here, draw a straight line, I don't know, and then you take your protractor and then find a 30 degrees angle, yes? And then you take your ruler and I don't know, but there are some ways that you can draw perpendicular lines, and then you do it, okay? And now I ask you, what is sine of 30 degrees? What do? You take your ruler, measure this length, turns out to be A, and then you take your ruler, measure this hypotenuse length, turns out to be B, and then you do A over B, you get a number. Yes? So do you understand? This is the setup that you can do. But now I ask you the same question in this new context. So what you are supposed to do now? So in this new context, if I ask you the same question, you will tell me, okay, let me draw a unit circle first. So you put the middle of the campus and open it one unit and then draw an egg rather than a circle. Yes. So let me try to make it a little bit better. Okay, so then you have this. Okay, and then what do? You take and rotate 30 degrees. So 30 degrees is more the same because you take your protractor, then draw 30 degrees. And then what do? You get this point, and then you read the x and y coordinates. For sine, x coordinate is irrelevant. You read the y coordinate. And then you read the y coordinate and say that sine of 30 degrees is the y coordinate. Okay? Now the question is that, is there any guarantee that this y coordinate that you get here is exactly A over B that you get in that setup? So that's an extremely important question to address. Is that understandable? So I have not calculated. To be honest, I measured things with protractor and ruler, and then at the end I calculated this, it becomes a number. But here I'm just going and read the coordinate, I get this number. So if this number is y, and the same number is supposed to be this, and if these two numbers are not always the same, then I will be really in trouble. So then it depends in which way you have to calculate sine of 30 degrees. Which one is which? Is this a better number or that's a better number? But the point is that no matter of confusion, always this number is equal to that fraction. But can you tell me why? Yes?
No, but can't we let's say we have the point that you just is B,
Yeah.
and then we have point A down there. Could we make a chord to make a triangle and somehow figure it out?
No, if you that's somehow close to this what I want to say. But if you make the chord, there is no guarantee that when you make this chord, it becomes a right angle triangle, and it is not in this case.
Okay.
Yes. So, but the thing that you mentioned is very close to what I wanted to mention in a different setup. So what is my question? My question is that in this way that I did it for you, prove me. If you ask me what is y, I don't know. If you ask me what are a and b, I don't know. I just randomly do, okay? But try to prove me that y is always and always equal to a over b. First of all, I want to make sure, do you understand there is a problem, yes? Mm-hmm. Because I calculate sine of 30, I got a over b. I calculate sine of 30, I got y. But which one is true?
Sure.
If they are different, I have to tell you which one to choose because they are different. But I am saying now the situation is much better. Always and always they are the same. For the cases that you can use both setups, it doesn't matter which one you use. But of course, we always use this unit circle from the time being. But there are no differences. Why is that? Because what Maximilian said, instead of drawing a chord, don't draw a chord. Draw a vertical line here. Yes? Okay, and then this length is y. Yes? Now, my question is that I'm claiming, and I want to wait for you to prove it for me. This is a right angle triangle. The one that I constructed here is also a right angle triangle. There is no guarantee they are identical. Of course, you can see in my picture that's much bigger. But I am claiming that that triangle that I draw is always similar. You remember we had similarity in Math 2C. It's similar to this triangle. Why is that? You remember the theorems for similarity? One of them was very famous. What was that? If two angles from one triangle are equal to two angles from another triangle, they are similar. And if they are similar, means that the ratios of the corresponding sides are equal. So are these two triangles similar? Yes. Because one of them is 90, 90, and then one of them is 30, 30. So these two triangles are similar. When they are similar, it means what I can write. I can write this length, which is y, over the corresponding length, which is a, is equal to this length, which is what? What? 1. It's the unit circle. Is over b. Yes or no? So y over a is 1 over b. So what is y? I multiply everything by a, it becomes a over b. So I was able to show that y and a over b are the same numbers. Yes?
Well, but why did you put y over a if you wanted to read?
No, I'm just writing the similarity. When you say two triangles are similar, it means that the ratio of the corresponding sides are equal. So I take the ratio between this side and that side. This is equal to the ratio of this side and that side. Yes?
Yeah, yeah.
So this means that, yeah, we don't need to be worried. So you can sleep very nicely, okay, in the night. So you don't need to be worried about collapsing or something. Anyway, so this was actually very important to address the question now. Okay, I would say that because we will have another session, so it would be better if we just stop here and then continue the next session, okay? Any questions? Okay. Thank you.